Okay, today we're having a look at outliers. Now, an outlier is one or more, maybe two or three at the most, numbers that are way bigger or way smaller than most of the other numbers in a set of data, okay? And quite often what we will do is, in the questions that you're going to be asked to do, is to look at the effect of an outlier on the mean, the median, the mode. And we do this by calculating with the mean, with the outlier in and then without the outlier, okay? So that's what we'll do this morning here, okay? So here's our set of data up here, okay? Now, we have 10 scores. Okay, most of them are fairly similar. So to find the mean, again, we just add them all up and divide by 10. So that comes to 90 divided by 10. So our mean is 9. Okay, and to calculate the median, we put the data in order because there are 10 scores. We add them together, okay, divide by 2, we get 5.5, which means because it's an even number of data, it's between the 5th and the 6th score in order. So 1, 2, 3, 4, 5, 6, okay. Here's our two middle scores. Clearly they are the same number, so we don't have to add them together and divide by 2. The median is 6, which is less than our mean, and this happens when we do have an outlier. If we have an outlier that's bigger than most of the data, then our mean is usually bigger than our median, okay, which is what's happened here. Now the mode, again, we're just looking for the number, the score that occurs the most often, and here it is here. There are 3 scores of 6, okay. All right, then you'll be expected to identify the outlier. Now, I don't think that takes a lot of sort of working out. There it is there, the number 36, way bigger than the rest of the numbers. Okay. Now, let's have a look at the effect of an outlier by removing it. Okay, which is quite often what we'll do with sets of data, is take out, when we want to do some analysis, like mean, and do some comparisons, we will often remove outliers. Okay, so now here again, we've got the same set of data, except we've taken out the number 36, and therefore this time there's only 9 scores, so we divide them by 9, okay? Now they add up to 54 divided by 9, and now we can see our mean is 6, down from 9 it was, okay? The median we put in order again. Now this time there are only 9 sets of data, or 9 scores. So 9 plus 1 divided by 2 equals 5. Okay, because it's an odd number of data, there's only one middle. It's the 5th score. 1, 2, 3, 4, 5. Okay, it's just the 1, 6. So the median, as it was before, equals 6. And the mode again, here is the 3 6s, so the mode is still 6. So as you can see, the presence or absence of an outlier, okay, has a much greater effect on the mean than it does on the median or the mode. It almost never affects the mode, okay, because the outlier is never the mode. If it was, it wouldn't be an outlier. If there were like 3 or 4 scores of 36, then we wouldn't consider them outliers, okay? Also, the median usually is not affected, but it can be, for example, if by removing one piece of data, okay, we might have, under different circumstances, we might have slightly changed the median, okay? Changing the size of an outlier has no effect on a median, but removing it can move the middle score one place to the left or the right. Okay, that's pretty much it. Please get on with questions 8.5, from exercise 8.5. Thank you.